Last lesson, we looked at the idea of the types of sampling, if you recall. We talked about different samples like sampling, like systematic, simple, random, self-reflection. Can we remember what they were about? So what's the difference between, say, something like a systematic sampling method as opposed to a simple random sample? Can we remember what the difference is? So with systematic, it is every so many. So we might select a person every fifth person or what have you, whereas simple random, yeah, you can pick names out of a hat or put everyone's name in a hat, pick names out of a hat or whatever it happens to be. We could also use a random number generator to select the samples, and that's what we're going to have a look at to start with today. There was also a stratified sampling, so that was looking at different strata and selecting in proportion to the number in each strata. So something like schools where you've got different year groups is a really good example of stratified sampling, probably the most common. And then we had self-selection. So self-selection is the one that is least valid because people are opting in to that kind of survey or questionnaire or it is that you're trying to get information about. So there is, that one's certainly not as effective in terms of gaining data that's unbiased. And we'll talk a bit more about bias in the lessons to follow. But what I wanted to have a look at today formally is this idea of using a random number generator to select a sample. So we haven't done that before, and I thought you might find this interesting, and I found a site that actually does a really quick, simple way of selecting a random number generator to help you select a sample. So if you, the idea is that each member of the population is assigned a number. So that could be people, but it doesn't have to be. Like you might need to sample, you might be a geologist and you might need to sample, you know, all the different rocks, and you might have an area in which you need to mine through or what have you. So you could have sections, different sections, and each section, say a metre squared or 10 metres squared or whatever it is, section might be allocated a number, and then you're going to randomly select a section to try and find information about the rocks within that particular section of land or what have you. There's an example there about area of grass for weed content. All right, and then we'll use the random number generator to draw the sample. So the one that I found looks like this. So if you just click on to that particular link that I've placed on the OneNote, hopefully it'll come up easily enough for you. So it's a really simple one. And what I like about this one is that you can use whole numbers quite nicely. So let's say you've got, I don't know, 100 people in your list. If you go maximum 1 to 100 and then click generate, it'll randomly select a number. So you would say, right, I've got 100 people I need to I could survey from. I want to select 30, and then you generate random numbers. So 37 is the first one, 27, 85, and you just keep hitting generate. So each of you, when you do this, will get your own list of random numbers. So keep that one in mind, and then we're going to have a look at a problem to work with. So here we have a class of students, and I want you to assign each student a number from 1 to 24. Let's do that now. So for me, I've got my 24 numbers, 24 names. Then I'm going to go back to that website, and I'm going to this time put a minimum of 1 with a maximum of 24 and randomly select 6 numbers. So 21, see if I can remember this, 21, 17, 3, we'll start with those 3. So I've got 21, 17 and 3, 19, 14 and 13. So 19, 14 and 13. So if I was going to survey 6 people from this list, they would be the 6 that I would be selecting. So that's just done using a random number generator. Now, you would have 6 different names most likely. The chances of you getting exactly the same 6 would be very, very slim. But you could have there could be some overlap for sure. So that's how you do it. That's how you use a random number generator to select your names. And then from there, you find out the information you need to find out about what have you. Now, if the same number is repeated on your list, so let's say that number of, 21, Joshua 21 came up again, you would just discard that and grab a new one because you don't want to ask the same person twice. All right. Okay, so Excel also allows you to generate random numbers. So if you're working on a spreadsheet and you've got data on a spreadsheet, now I've got a spreadsheet for you that is the list of all the Year 12 students at the school. You can see it there, there's a link. So that's all Year 12, so nothing like real life data to get you interested in this. And what Excel does is it's got a couple of options. So the 2 options, it's actually got more than 2, but the 2 options I'm suggesting, or probably the most common one or easiest to follow, is the rand between. So what that rand between does is it allows you to select a random number between 2 values. So very similar to the one that we did on the website. And if you just type in equals rand between, see how the instructions are here. So this is the instructions up here. That's what you type in a cell. And then these are the 2 values you want the random number to be between. It does include the 50 and the 75 as well. We don't necessarily want 50 and 75. We're going to do that in a minute on our spreadsheet. And then you can either fill down, I'll show you how to do that or remind you how to do that in a moment, to get more random numbers. So for me, that's probably the easiest. There is also a rand array, which is another instruction that allows you to get a certain number of random numbers in one hit. And it places them in a, however you want to place that array. So it could be 10 rows, 1 column, or let's say you want a 2 by 5 table with those numbers, random numbers in there. And then we say true, also says true to say, right, well, that's the true is about whole numbers. If you don't have true, it'll give you decimal numbers. So most of the time, what we're dealing with will be whole numbers. All right, so clicking on the spreadsheet, we're going to generate a list of, randomly generate, let's see if we can pick your name. Randomly generate a list of 10 students. So this is the list of the Year 12 students, and you can see that I have already numbered them for you. The numbers on the side are just the numbers per year group. We're going to use that later for a different type of sampling, but you can see here there are 109 Year 12s at the school currently. And if we want to generate a list or a random number, pick a random number, then we need to just click on the cell. Can anyone remember what we need to do? Equals first, because it is a formula type thing that we're trying to put in. And then if you start typing in rand, you can see there's some options. Now, rand just gives you random numbers as decimals, a bit harder to interpret, which is why I prefer rand between. So if we just click on rand between, you can see it coming up on the top of that spreadsheet. Oops. And then you've got a choice. You can actually, and probably easiest, is to say I want a random number between cell A1 to cell A111, or you can just type in 1 to 109. So there's your the 109 students, as opposed to the placement in the cell, which actually starts at A3, not A1. Sorry, that was my mistake. Okay, so doing that, you can see my number has come up as 38. So student 38 Let's see who was lucky enough to be chosen. Right, Cara, there she is. She is the first person or one of the people I might survey if I want to find information about something. Now, rather than doing RAM between heaps of times, I did say we want to select 10 people. The other option is to fill down. I mentioned that before. So the quickest way to fill down is to grab the bottom corner and just drag it down 10 places or however many you need, and it repeats that instruction. You could go to edit fill down, but quickest way is to take that bottom corner and then you can see it repeats the instruction. So each of these are different random numbers. They are the different students that I'm going to select for my survey. So I want you to do that and write down, I think I said write down the 10 students, or at least highlight them on your spreadsheet. So I've got student 68. Simran's the next one. Then student 16 followed by student 11 and so forth. Oh, Tali's been selected. Hannah. 86, 107. So, oh, Emily's been selected as well. Xingyu and so forth. You get the idea. So they are, for my selection, the 10 students. You will have 10 different students. There might be some overlap, as I mentioned, just like previously. So it was just getting you used to a couple of examples of how we can generate random numbers and then use that to try and select your sample. And at least this way we can see that it's truly random. Whereas if you if you pull names out of a hat, that's another random method as well. But if you just, go to randomly pick some names, you might be, influenced by certain people. You might pick a few more that are your friends or so forth. And so to avoid that, this is what we do. All right, so that's using a random number generator to generate a simple random sample. Now, remember last time I said usually we would sample a minimum of 30 to get enough information. Doesn't matter how many in your list, a minimum of 30, and then ideally the square root of the population, the target population number is what we would be trying to aim for. All right, so that is simple random sampling. We can still use the random number generator to generate our names in a stratified sample, but we need to do one step first prior to that, and that is looking at actually calculating how many in the strata first. So I'll let you read that question. In fact, you can see here 590 is nearly double. In fact, not quite, but nearly double. There's a lot more females, so you want to survey a lot more females than males. And so before we work out how many of each we want to survey, we're told that 10% of the members she wants to survey. So if there's 970 people in the gym, then she wants to survey 10% of 970, which you should know is what? You shouldn't need this calculation really. 97. How many females? Well, 10% of the 590. So that's 59, and with your males, you've got 10%, so 38. So you'd be surveying more males, sorry, less males, more females, because there's more females in the population of gym members. And that is the target population in this instance. Any questions about that? So let's say once we've selected our 59 females, then we've got a list of all the female members. We could then use a random number generator to generate 59 random numbers, and that'll link to 59 names on our gym list. And then we would repeat that for the males. So what that strata does, it separates the groups. So you've got your females in one group, you've got your males in another. There's more females, so you're going to make sure you survey more females. Otherwise, if you just did a simple random sample, you could technically call out 97 names and all of them could be male, for example. Unlikely, but possible. And so by stratifying, you're fixing those numbers so that you are definitely going to survey 59 of these, of the females, and you're definitely going to survey 38 of the males. And that way it's fixed, and it is then in proportion to the target population. All right, so that's one example, using a percentage of the number. Another example is using a different strategy. So I'll let you read this question as well. This is real life data. Okay, so these numbers I pulled off our database, I don't know, it was late last week sometime. So nothing like real data. There's 706 students in our senior school, and they're the numbers. So quite a large number of year 11s, and even 10s for that matter, compared to say year 7s. So if we want to survey members of the school students, then we might want to select a few more year 10s or more year 10s compared to year 7s because, or year 11s, because there's more of them. And so I've asked you to have a go at how many we would survey. So this time, rather than surveying a percentage of students, Miss Ag was definitely fixed. She's got 32 time slots. She wants to survey 32 students. So how do we make that happen? So if we've got a stratified sample, then the number of students is in proportion. So here, the way we calculate the number of year 12s, you've got 109 year 12s, you've got 706 students in total. So it would be that proportion or that fraction, 109 out of 706. So that fraction of the 32 students. So this one's slightly trickier. So we've got 109 12s out of the total 706 times 32, and then we just round to the nearest whole number, whatever that ends up being. So I'll let you dig your calculators out. I probably need a calculator here. Mine's still not working on mine. And times 32, and we get 4.94. So like I said, we round to the nearest whole number, just making sure that at the very end we don't exceed that number of 32, or we don't go below that number of 32. So 5 year 12s we'd be surveying. Repeat the process for the year 11s down to year 7s. I'll give you some time to do that. All right, so from here you can see now that I've done all of them. There's not a lot of difference, but at least we can take into proportion the fact that there is less year 7s and 12s compared to the other year groups, even 8s for that matter. So we are going to notice I've rounded those figures to the nearest whole number, and then we just do a quick scan at the end to make sure it adds to 32. If we're out by one, we just adjust the closest. So this one of them was pretty close, like that 5.53. We might have needed to adjust that number. So what I mean by pretty close, as in it's close to 5 or 6. So we may have had to adjust down, but in this case we don't need to worry. We've got 6, 12, 18, 23 plus 9 makes 32. So 32 is who we're going to survey, and you'll notice they're 5 year 12s. So then I've asked the question, right, how could those 5 year 12s then be selected? Use your list and do it. So you've got your list of year 12s. I want you to select 5 of them. I want you to do it in a way that would be random. So going back to our spreadsheet, generating 5 random numbers using the rand between, we'll do it. And my random numbers were 37, student number 37, 49, 105, 92 and 12. And so from those numbers I would then go to the list and get the names, but we'll move on from there. Okay, so that's simple, random, stratified, and then the next one is systematic. We're going to look at that one as well. Now systematic is a bit different because we are targeting every so many of the population. And so in the previous question, we used a simple random sample by just randomly selecting those 5 numbers using that random number generator. But in this case, we're going to select 5 students in a different way. How could we do that? So there's 109 students altogether, and we need to select 5 of them. How will we do that? I'll let you think about it. So doing 109 divided by 5 gives us, say, every 22nd student to the nearest whole number. So the question begs, well, okay, so every 22nd student I'm going to count on my list. Do I start at student number 22? Do I start at student number 1? Where do I start, actually? In fact, if I start at student number 22, I'm going to run out because I've only got 109 and we've rounded up to 22. So we've got to, that's something to the side we've got to be a little bit careful about. It's actually not good to just start at student 1 or just start at student 21. What you should actually be doing, the correct mathematics, is to actually randomly choose your start point using a random number generator. So if I say, right, it's got to be somewhere in those first 21 students, I'm going to generate a random start. So student number 15. That's my start point. And then as soon as I do that, so random start between 1 and 21, so student number 15, then I can add 22 students later. So then it will be student 37, and then 20 students after that is going to be student 59, and 22 students after that, student 81, and then 22 students after that, gosh, I'm getting tongue-tied, student 103. So that is a random process, but with a systematic approach. Any questions about that? So we've randomly selected our start point and then systematically selected the rest. So adding 22, and then go back to your list, and those student numbers are the ones we're going to select. So 22 along the way. Now, just be careful about this kind of selection. So I'll let you read the preamble there. But particularly if we're talking machines and we're checking whether things are defective or not, off a production line, I'm sure you've seen those production lines in the movies, even in lots of cartoons, they have those production lines of cool drinks and stuff coming through. You might miss something defective, or conversely, you might be always picking a defective item. So there might be something wrong with machine number, 22. And so if we keep picking that, there's only 22 machines, then we've got to be careful. We've got to be careful not to miss as well. Okay, so there's a practice question here. Let's have a go at that now. So because of the 4 distinct groups, we've got 11 out of 160 male admin staff, and we want 18 members. So 18 members, so 11 1/60ths of 18 is really what we're looking for there. And then we repeat for the females who are admin staff, and then the male factory workers and the female factory workers. So they're your 4 groups, and you should have about double female admin staff compared to male admin staff being surveyed, and then you should have double again the female factory workers and then a bit more male factory workers. That should be the highest number because that's the highest number of staff in the company. So this final question before we do some practice is just more out of interest because it's a bit different. This is more a geological type question. We're looking at seals. You can see here those 900 squares that have been placed on that grid are all representative of an area that in real life covers 10,000 metres squared. So it's a 30 by 30 grid, and the idea is to look at all of those squares, and we're interested in the number of seals present. And I want you to think about some of these questions and statements about that, and could there be any improvements in the plan? So I have got some solutions to this, which I will place up on the OneNote once you've had a go at thinking about it.